Here's a real quick look at some load analysis that's really good for you to learn how to do if you're going to um, be doing some design work. So what we've got here is we've got a bracket. It's going to get screwed into the wall right there. Okay, so let me go ahead and draw the wall. I'm going to draw a really thick pen and I'll draw the wall. There's the wall right there. And it's thick, and there's going to be some sort of a screw that goes right into there. Okay, so that's what's going to be holding it into place. And then there's going to be a screw going up this way that's going to help hold this on. And that's sort of what this bracket design is like. But now let's take a look and see what happens and where the loads are and what's going on. So if I put a force on it out here, let's say I put a coffee cup out here, and that coffee cup weighs 1 pound. Okay? You go, well, that's not too much, but you know that as this goes farther and farther and farther away, that 1 pound out here does a whole bunch in here. So let's take a look and see what those loads do and how those transform, and we'll do a little bit of math with it too. So I'm going to draw a nice cup of coffee right over here. So there's a cup of coffee, and it looks like an ear, doesn't it? So I'll have to say coffee. There's the coffee in there. There we go. I've got my coffee. And what that does is that gives me a load downward of 1 pound. Okay? I know that's heavy for a cup of coffee, but we're going to pretend it's 1 pound out there. Okay? And I know that this is about 12 inches away. So what is that 1 pound of coffee out there going to do? I've got a screw in here that's holding myself into the wall. Hopefully it's into a stud, and that'd be cool. So I've got my 1 pound out there and here. And what's that going to do? That's going to make it want to kind of go like this, right? This whole thing is rigid because I've got a nice, strong piece of plastic. I'm thinking it's strong. And a strong piece of wood or something like that. So this is going to want to twist this thing down. It's going to want to turn, and it's going to try to pivot about that point right there. Right? That's where all the load is actually really going to focus. Right? It's pulling away up there, and it's pushing in right there. So that's where all the load is going to go. And the only thing keeping it from doing that is the force of this screw. So that screw, the force of this screw, has to counteract what's happening from that. Well, I can make an equivalent force here. This thing, coming like that, is making what's called a twist or a moment of 12 inches times 1 pound. 12 inch pounds around that. 12 inch pounds because it's 12 inches away. If it was 6 inches away, it would be 6 inch pounds. If it was 24 inches away, it would be 24 inch pounds. It's how many inches away times how many pounds. So let me write that one down. That one's going to be 12 inches away times 1 pound equals 12, and they call them inch pounds. So that's what's happening there. There's some sort of something happening like that, making it twist with a number called 12 inch pounds. Well, you know, good old Sir Isaac Newton came up with a cool thing that said if something's twisting at 12 inch-pounds that way, something has to be keeping it in place the other way. And the only thing keeping it in place is this bolt. And so that bolt has some sort of force that it's developing in the threads, and it's got to kind of hold the twist going the other way. And that is this distance times whatever this force is. Okay, well, I know that distance, it's about 0.5 inches. So I can say whatever that force is in that bolt, force in bolt used to hold against the coffee times 0.5 inches. And I don't know what that force is right now. Okay? But I can find out what it is because I know that F times 0.5 has to equal this 12. So, F times 0.5, F times 0.5 has to equal 12 from my other side. Well, that's cool. I know how to do that, right? To get this alone, I put this on the bottom. So I can say then, I can say that F equals 12 divided by 0.5, which equals 24. Better make that a capital F. So every pound I put on this shelf out here is going to be 24 times on here. That's a lot. That's a lot. So how do I reduce that? You know, that's pressing into the wallboard. I've got to have a pretty good molly bolt. That's only 1 pound. What if I have 2 pounds? And that's a 50-pound load on that screw. And so I want to make that as good as I can get. All right. So what would I do? It's this 0.5 number that's really messing things up, right? This number isn't very big. I could always make this a shorter shelf. Right, I could make it a 6-inch shelf. That would help. But maybe then you can't put as much stuff on it. So these are the things that you would do as a designer now. You would say, oh, I'm going to limit this to a 6-inch shelf, and I'm just going to put little knickknacks on it that don't weigh anything. I'm going to do my paper origami collection, because that only weighs... The whole thing only weighs 1/4 pound, and it'll fit on 6 inches, right? So you can always change it so that it's not very big and it doesn't have very much weight. Or I can do something with this number right here, this 0.5. And I know that if that number was bigger, it would be good. So if I had something sticking down here that this would press against, even 2 inches long, that would then be 12 divided by 2. I'd be making things much bigger. So that says that maybe I want to add to my design a little piece down here. And it doesn't even have to bolt in. It just has to be something so that when this is spinning, this presses against the wall down here instead of everything being happening right there. So now I've got 12 divided by 2 for my thing, and I get 6. Makes a huge difference. A huge difference. So in your design, you may wish to add a little piece hanging down here Doesn't even have to bolt in, just has to be there to press. And you can even do cool design things on it if you want. You can make it look kind of cool. You can put different shapes on it. You could put a star on it. All sorts of things you can do to help that out. Okay? So there's a little bit on design and loads that you can look at as you're working on this.